Okay, here's the math to go with it. So the logic is we're going to angle to the west. I'm not sure how far we're angling to the west. We'll do the math to get that. We're going to get this angle down here, or we're going to angle to the west so that we end up coming back straight south. Good old Pythagorean theorem again, but this time we know the hypotenuse. So 170 squared equals 60 squared plus the unknown side. I'll let you do the math on that, flip-flop things around, rearrange, square root. When I'm all done, I get a number of 159 kilometers per hour. That's how fast the plane is moving relative to the ground, pointing straight south. We know the distance straight south was the distance to Pittsburgh. That was the 340 kilometers. If we use our v equals d over t equation again, our speed this time is 159. Because we're fighting the wind, we're not going as quickly over the ground. When there was no wind, all 170 kilometers per hour of the plane were pointed south, but this time because we're on an angle, we don't have that same full 170 going south. We're only going south at a rate of 159. The 340 goes in the numerator, and we're going to solve for time again. When I flip-flop things around and do the math, I get a time of, it's not significantly different, but 2.1 hours. So it would take the flight a little bit longer in the case where it has to correct for that wind to end up going straight south. Now, if you were the pilot, we can go one step further. If you were the pilot, we can find what angle you actually fly at. If we go back to the purple triangle, I know that the opposite side to the x is the 60, and I know the hypotenuse is 170. I know the adjacent side now too, but I don't want to use a rounded off number. So if we go back to my triangle, I know the opposite is 60 and the hypotenuse is 170. So doing SOHCAHTOA thinking, that's a sine relationship. The sine of that unknown angle is 60 over 170. Depending how you work your calculator, we're going to go x is sine to the minus 1, 60 over 170. When I did this on my calculator, I got, within rounding, 21 degrees. Now to describe that, to put it in that square bracket notation, really we're flying 21 degrees west of straight south. If you wrote it out that way, that would be fine by me, but the square bracket notation that textbooks and other people use, from straight south, I'll switch colors. This first, our sort of reference line was straight south. From straight south, we rotated, and the number we happened to rotate was our math. We happened to rotate 21 degrees, and our rotation was towards the west. So in square brackets, we're going to say south, 21 degrees towards the west. That's our sort of last, most complicated concept for relative motion, how we deal with it when there's a wind and the plane wants to angle into the wind. I could just as easily make up a question where it's a boat fighting a current. The logic ends up being the same. The speed of the boat becomes a hypotenuse and it angles against the current. In this case, the speed of the plane became the hypotenuse and it angled against the wind.